Okay, today we're going to determine the standard equation of a circle given a diameter with endpoints at -4, 3, and 2, 3. Take note, for us to determine the equation of a circle, we need the center and its radius. But before that, let us recall first the equation of the standard of a circle. So we have x minus h squared plus y minus k squared is equal to r squared, in which the center is at hk. Now, since the given is endpoints, we need the center. Now, if this is the diameter, the center is at the middle, right? So that is why we need the midpoint formula. Okay, this is the midpoint formula. We have x of 1 plus x of 2 over 2, comma, y sub 1 plus y sub 2 over 2. This is the midpoint formula. So, we will assign the x sub 1 and x sub 2, y sub 1 and y sub 2 here. So, if this is the first point, we'll assign this as x1, this will be x2. If this is y1, this is y2. So, continue by substituting the value to the equation. So, x1 we have -4 plus x2 we have 2 over 2, comma, y1 is 3 and y2 is 3. So, we have 3 plus 3 over 2. So, we have -2 over 2, comma, 6 over 2. Therefore, the center is at -1, 3. So, we have the center now at -1, 3. Now, we need to solve for the radius, right? Because in solving for the standard equation of a circle, we need the center and the radius. But how? Paano? How do we solve the radius here? Now, the radius is the distance, right, from the center to any point on a circle. So, since we have solved the center, -1, 3, we need another point, okay, on the circle. For example, if we will be using this point, 2, 3. So we need to solve for the distance from -1, 3 to 2, 3 as our radius. Okay? We need the distance from -1, 3 to 2, 3 to solve for the radius. So, to recall the distance formula, we have d is equal to square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay? So, if I am going to assign value here for x2 and x1, this will be x1 and this is x2. This will be y1 and this will be y2. Okay? It can be interchanged if you want to use this point first. This will be x1 and y1, x2 and y2. It can be interchanged, no problem, because distance is commutative. When we say commutative, if Sipak from Morsia is the same with Morsia from Sipak when we talk about distance. So, x2 we have 2 minus x1, we have -1 squared plus y2 is 3 minus y1 is 3. raised to 2. So to continue, we come up with square root of 2 minus negative 1 will give you 3. So that is 3 squared. Plus 3 minus 3 is 0. So 0 squared is 0. So we have square root of 9. And the square root of 9 is 3. Okay? So 3 is the radius. Now, we have the center and we have the radius. Then go back to the equation. X minus h squared plus y minus k squared is equal to r squared. So x minus h, center is negative 1. So minus h is negative 1. Then squared plus y minus k is 3. 3 squared. R is 3. So that will be 3 squared. Okay? So we have the formula is x plus 1. This will be positive. Negative times negative is positive. So plus y minus 3 squared is equal to 3 squared. So we have now the standard equation of a circle whose endpoints is at negative 4, 3 and another example. We have a center at 6, 2 and tangent to y-axis. We're going to determine the standard equation of a circle which the center is located at 6, 2 and tangent to y-axis. Before we proceed, let us familiarize first this word tangent. When we say tangent, that is a circle passes through a single point on y-axis. Right? If you're familiar with a tangent line, if this is a circle and this is the line, this line is tangent to this circle because this line only touches single point on a circle. This is a tangent line. Since the problem states that tangent to y-axis, then if this is the Cartesian plane, the x-axis and the y-axis, so this is y, this is x. When we say tangent to y-axis, if the circle is here, okay, then the circle touches single point only on y-axis. That's it. That is meant by tangent. Okay, I hope that is clear to everybody. Now, let's proceed. 6, 2. If we're going to graph 6, 2, say 1, 2, 3, 4, 5, 6. Located at quadrant 1, 2. 1, 2. Of course, the center is here. Okay? So, since the center is here, and the circle is tangent to y-axis, so, of course, if this is the radius, okay, of the circle, so this point here, it only touches, what point is this? This is point 0, 2. Okay, without solving, by locating the point or the tangent point that is 0, 2. Of course, if we're going to make a graph, the circle is here. Since siya nasa circle. Okay, sorry. Circle is here. Okay. It touches only a single point on the y-axis because it says that it is tangent to y-axis. Now we have this point. Of course, the center is at 6, 2. And the radius, just count 1, 2, 3, 4, 5, 6. Because the radius is equal to x this time. Why? The radius is equal to x because it touches single point on y-axis. So, since r is equal to x, then r is equal to 6. So, we are done. Recall the formula: x minus h squared plus y minus k squared is equal to r squared. Then, x minus h. H is 6 squared plus y minus k, 2. 2 squared is equal to r squared. You have 6 squared. So this is the standard equation of a circle in which the center is located at 6, 2, and that is tangent to y-axis. Condition: if the circle is tangent to y-axis, always remember that r is equal to h. Like this. This is an example of a circle that is tangent to y-axis. So, the radius is the distance from the center to any point on the circle. That is why this radius is equivalent to this, in which this is the h, right? Okay? This is the h. If this is 4, okay? So this is also 4. And condition number 2, if the circle is tangent to x-axis, r is equal to k. Like this. This circle is tangent to x-axis. So if this is r, this is the k, right? This is 4. 1, 2, 3, 4. So this point here is 4. Okay? The k is 4, right? That's it. So, always remember, if tangent to y-axis, r is equal to h. If tangent to x-axis, r is equal to k. That's it.